Hello, this video shows you how to use Edge AI Studio's Model Composer for image classification. This is a cloud-based tool that helps make Edge AI easy for novice users. Let's start by creating a new project. At present, only image-based tasks are available. Select Image Classification. At the top, you will see a number of tabs that guide you through the process of capturing data, annotating data, selecting a model for training and compiling, all the way through to deployment. This icon provides a hint as to which task we should perform next. To start, we need to create a data set of images that we will use for training. There are two options to capture live images. We can use a camera connected directly to your computer or a camera that is connected to your development board. I will use my laptop camera. If you do not see your camera listed, press this button to refresh the list and choose Yes to enable the camera within your browser when prompted. Now you should see your camera listed. I will use my HD camera and JPEG format. For this demo, we're going to see if we can classify the difference between a person and someone wearing a fire marshal costume. So I'll take a few pictures with the costume on and a few without. The thumbnail of new images are shown on the right side, and you must pick and choose which of these images you wish to upload into your project. I will select all. The next step is to annotate the data. This is the process of providing the correct answer for training and validating a neural net. In this case, we only have two classes of images. Use the plus icon to define these classes. I will use person and fire warden. Next, tag each image with the correct classification. We will need a lot more images than we currently have to properly train the model, so let's go back to the Data Capture tab. Here we can import images from your computer, or in my case, I will import an already annotated dataset. Now that we have annotated data, we can jump to the Model Selection tab. Here we are asked to provide two pieces of information. The first is what device we will be using, and the second is the model. Since I already have hardware, I will choose it specifically. These are the devices we currently support. I will select this one since I have an AM62A Launchpad sitting on my desk. This tool relies on transfer learning, so now we must select a model to be retrained using your dataset. Since I am a novice and do not know which model to use, I will go with a recommendation. Here I can choose a model based on the trade-off between accuracy and performance, and for this demo I will use the one with the fastest performance. Below the device selection you can find information about the selected device if you are not familiar with it. Similarly, you can see information like the inference time and resolution used for the selected model. Once we have selected a model, we need to train it with the data set we created. There are a few parameters you can use to control the training. I will use less epochs to make it go faster, but in general the defaults should be fine. Each epoch represents one iteration over the entire data set. As the training proceeds, you will see the graph to the right fill in, and detailed log information to the left. After training, we need to compile our model. The active model drop list shows a history of training runs. Each training run can be compiled for different devices for comparison. To make it easy for novice users, we have a number of preset configurations ranging from fastest speed to most accurate for the compile step. For this demonstration, I will use the fastest setting. This setting may take more time than training did and includes quantization and optimization of the compiled binary. Now the compile has completed successfully. You can see the accuracy obtained here. In addition, a selection of images used for validation are displayed. You can see each image is correctly identified as either a person or a fire warden. If you have hardware, you can run a live preview of the compiled model. This is the hardware configuration I am using. I have my board connected to my local network using an Ethernet connection with a USB camera connected directly to the board. I also have an optional USB data connection to my laptop. First, I will connect the device. To connect, I need to provide the IP address of the Ethernet connection of the board. If you need help, follow the instructions on the help link provided. For convenience, there is a search icon to automatically obtain the IP address. This uses that optional USB data connection to communicate with the board and obtain the IP address. It also starts the device agent program that this tool communicates with automatically. So this is the camera input. This is what the device we use for inferencing. So let me start the live preview. It's going to download the model to the target and run the model on the target and stream the video through the Ethernet connection back to the browser. So as you can see, it's correctly identified me as a person, and if I put on the fire marshal or fire warden costume, it should detect me as a fire warden. If you are satisfied with your results, the last step is to deploy the model. Here we can download various artifacts to your PC, and we can also deploy directly to a connected device. The deployed model can be found in your projects folder. And that's all there is to it. Thank you.